In today's lecture, we are going to discuss about operational amplifiers, which is in short known as op-amps. So what is meant by operational amplifier? Before looking into that, let us see what is an amplifier. So amplifier is a device which amplifies the amplitude of the signal. That is, my y-axis will be multiplied with the gain. That is known as amplifier. Suppose here if the input signal's amplitude is 1 volt and if this amplifier has a gain of 3, this 1 volt will be multiplied with this gain and here the output voltage will be the same signal with an amplitude of 3 volt. This is the function of amplifier. So what is an operational amplifier? Operational amplifier or amplifiers which can be used to perform mathematical operations like addition, subtraction, integration, differentiation, comparison and so on. So let us discuss about the symbol of operational amplifier. So this is the reason why amplifiers are known as operation. So an amplifier which can be used to perform mathematical operation is known as an operational amplifier. So this is the symbol of operational amplifier. It is an 8-pin IC and these 5 terminals are the common terminals which is being used. So if you see here, these 2 terminals are the input terminals. This is the output terminal and this is the bias voltage which is being applied. So here we have 2 input terminals. Out of these 2, one is the inverting input terminal and another one is the non-inverting input terminal. Here I have applied the voltage V1 to the inverting input terminal and V2 to the non-inverting input terminal and the saturation voltages are given as V and minus V. Let us see what is the function of the saturation voltage later, and we have an output voltage which normally will be taken from pin 6. Now, if you look into this working of this system, see, suppose if I give an input voltage V1 and if I ground this V2, then we say that this op-amp is an inverting operational amplifier. So at that time, my gain or the output voltage will be, see, this is a system which has an gain, and operational amplifiers are high gain differential amplifiers. They have gain in the range of 10 power 5 to 10 power 6. So this is a high gain amplifier, and so we will be having, if A is the gain of this amplifier, my output will be A into V1 which is being given to the inverting terminal. So we will be having minus V1 as the output. See, suppose if I am giving input to this terminal as V2 and if I ground this terminal, then it means that I am giving the input to the non-inverting terminal and so gain is obviously A. So gain A into V2 will be my output. So this is how outputs are calculated. So as I said, gain will be normally high gain for this operational amplifier. Coming to the third section, suppose if I give both inputs V1 and V2 simultaneously, then what will be the output? The output will be the difference of these 2 inputs. That is V1 minus V2 will be the output of this operational amplifier multiplied with the gain. Right? So this is known as the difference gain, and that is why we call that as differential amplifier 2. This. Now, so we have discussed about these 2 inputs, the 2 input terminals, how it works. If I give input to this input, what will be the output? If I give input to this terminal, what will be the output? And if I give input to both the terminals, what will be the output? Now the cases, see that as I said, operational amplifiers are high gain differential amplifiers. So suppose for example, I am giving an input of 1 volt. For example, let me consider here the V2 is 1 volt. V2 is 1 volt. And the gain, as I said, for an operational amplifier is 10 power 5 to 10 power 6 when it will be. 10 power 6. So see, the output voltage here will be 10 power 5 to 10 power 6, which is not feasible, which we cannot excel. So we need a saturation level to be fixed for an operational amplifier with high gain. For that, we have these 2 terminals which is used for giving the saturation voltage plus V and minus V. So see, if you see the output values or transfer characteristics of an operational amplifier, the operational amplifier's output is being limited to a particular value because the gain is infinite. Gain is very high gain, which is not feasible practically. Theoretically we can achieve, but practically it is not possible. And so see, with the help of this bias terminals, we will be limiting it to plus saturation and minus saturation. This is the voltage transfer characteristics of an operational amplifier. So to summarize, we have discussed what is an amplifier, what is an operational amplifier, why it is known as an operational amplifier, what is the symbol of an operational amplifier, what are the major terminals which we are using, inverting, non-inverting, output and the bias. What is the function of this bias is also being discussed. Thank you.